Hi everyone, welcome to this episode of Kuiper Labs. In this video we're going to be talking through the concept of ionic bonding, or compounds that form from ions. Okay, so let's do a little bit of a recap. So that when we're talking about this concept of an ion, that we're thinking about an atom or a group of atoms with a charge, with a positive or negative charge. Okay? So it could be one atom by itself, it could be a connected group of atoms that behave as a single group, okay, and that they form by gain or loss of electrons. And now what I'll even do to kind of give us a little bit of extra clarity here for what we're going to do next is this idea that they form by the gain or loss of specifically valence electrons, not just any electrons, but the ones in our valence electron shell. Okay, so our valence shell equals our highest energy / outermost shell. So the easiest electrons to remove, and then that the idea being that a full outer shell is the goal. Okay, so a full outer shell of electrons, so which is either 2 or 8. Okay, depending on which shell that we're talking about here. Okay, and how big the atom is. Okay, so the ones that have the full outer shell are noble gases. Okay, like helium and neon and argon, and those are the ones that atoms will gain or lose electrons to be like. Okay, but so now what we're going to look at is, okay, well, what happens when ions form with two atoms that are next to each other, and how they would interact once they do that? Okay, so we're going to look at a sodium atom, and we're going to look at a chlorine atom. Okay, so now what I'm going to do for sodium, so I'm just going to represent the positive nucleus in the middle. Okay, and then I'm going to just draw in these two inner shells. And then I'm going to use some coloured buttons to represent our outer shell. Okay, so we've got sodium, and let's make it red. And sodium has one outer shell electron, okay, as an atom. Okay, we get chlorine, so same sort of deal, positive nucleus, 2 in our middle shell, okay, and then what we have, okay, and then we've got 8 in our next shell, and then we've got 7. So 1, 2, 3, 4, 5, 6, 7 in our outer shell. Okay, it's in group 7, sodium's in group 1. Okay, so we can identify that that's the number of electrons that we have. Okay, so we've discussed in the past this idea that the sodium ion will lose this one valence electron to retain that full outer shell of the next shell. Okay, so that one will be lost, and we basically then we have an empty third shell, and we end up with a full outer shell, making a sodium 1+ ion. But the thing is that this electron isn't going to get lost in isolation. Okay, it doesn't just kind of get lost for fun. That what happens is that rather than being lost into nothingness, that it actually is, it's lost because it is gained by something else. Okay, so this one electron from the sodium doesn't just vanish, but actually it will move across to our chlorine, because we identify that we've got 7 and it wants to have a full outer shell of 8. Okay, and so it will gain this one electron to form a chloride 1- ion, okay, and end up with a full outer shell over here. Okay, so you can identify the electron that originally came from the sodium. Okay, and now we have a sodium ion and a chloride ion. Now what we know from science that you've looked at in the past is that opposite charges attract. Okay, and that like or same charges repel. Okay, now the phenomenon that we're particularly caring about here is this first one, is this idea that when we have things that have opposite electric charges, that they attract one another. So over here we now have a positively charged thing, and over here we have a negatively charged thing. Now what ends up happening is that these two ions, as kind of a whole thing, end up pulling towards each other. Okay? And so what happens is that they form what's called an ionic bond. Okay, so this is called an ionic bond. That is, by connecting together in this way, by pulling towards each other, that they get locked together in a way that's very hard to undo. Okay? And so we see this with any positive and negative ion that form. So let's have another look at a quick kind of another example. All right. Okay. So let's look at oxygen. So we're going to do oxygen over here, and let's do magnesium over here. Okay. So magnesium, with its positive nucleus, we've got 1, we've got 2. Okay, and then we've got 8. So we've got 2 in this shell, we've got then 8 in the next one. Okay, and then magnesium has 2 outer shell electrons. Okay, oxygen, with our positive nucleus, has 2 in this shell. And then what it has is it has 6, 1, 2, 3, 4, 5, 6 valence shell electrons over here. Okay, so we know that each one of these is going to want to get a full outer shell. Magnesium in group 2 is going to lose its 2 electrons. Oxygen in group 6 is going to gain 2 electrons. So what happens, as with before, that one of magnesium's electrons is gained over here, and the other is gained over here. We have a full outer shell for magnesium now. We have a full outer shell for oxygen. We now have two more protons than we do electrons, so we have a 2+ charge. Over here we now have 2 extra electrons than protons, 2 more than we did before, so we've formed the oxide 2- ion. So just as before, that the magnesium and the oxygen pull towards one another, and we form that ionic bond. Okay, so that's kind of the way that this works. Now what we can see is that, let's start to look at a slightly bigger sort of scale. I'll move those over here and we'll use them in a second. So let's consider our sodium and chloride. Okay, so let's say, rather than dots representing individual electrons, let the dots represent ions of a particular type. So let's imagine that our red dots represent our sodium, and then blue dots represent our chloride. So what happens is that, let's kind of shift those over there so we've got a bit of working space in the middle. Okay, so if each red dot, so this is a sodium that's formed, is attracted to a chloride, and then there's another sodium ion that's formed. Now what happens is, if I connect it over here, is that these like charges, these red ones will push away from each other, but this red one can be attracted to this blue one. Okay, and then likewise blue ones over here will push away from each other, but this blue one could fit in here and be attracted to the red ones and not touching the blue. Okay, and so what we end up with, when we look at this sort of an arrangement, we now get this alternating kind of checkerboard pattern of positive and negative ions that form. Okay, let's see if I can make this nice, neat kind of pattern over here. Okay, so what we end up with, this is called a lattice sort of shape. Okay, and so what we have is that we have ionic bonds that form between these positive and negative ions. Okay, and so the phrase that we would use, the slightly more scientific phrase, is electrostatic forces of attraction. Okay, that's the more scientific kind of terminology that I'd like for you to really kind of emphasize. Okay, that's how chemists would actually refer to the reason why these positive and negative things stick together. Okay, now the reality is that this is a nice kind of 2D representation, but the reality is that they actually kind of be a little bit yeah, there's a bit more of a 3D structure that kind of goes on when you can imagine them that kind of, this is forming a cube where they stack up high and in all 3 dimensions. Okay, where positives and negatives are attracted to each other, and but as far away as they can from the same charge. Okay, so we have ionic bonding. And what we have here is that now that we've actually formed a substance which is based on only these 2 ions, we say that this is now called an ionic compound. Okay, so it's a compound, a new substance formed from 2 or more types of atoms, but are specifically in the form of ions that are connected together. Okay, that ionic compounds will behave differently to other kinds of compounds that aren't made from ions, and we'll look at that in a future video. Alright, that wraps it up. Thanks very much for watching. Bye for now.